Hi everybody, welcome to video 2 in week 6 of our Principles of Microeconomics video series. In the last class, we really focused on consumer surplus and the concept of elasticity. Check out that video at the link above. In this video, we're going to focus on the producer's problem, how much to make, what to make, and so on. Let's get to it. So the producer's problem has 3 components: production, costs, and revenue. Production refers to how you make the good, the actual process. We need to understand that process before we can understand how a producer will behave and how much they will supply. Costs. When we talk about costs, we're talking about the costs of hiring the workers and the machinery and all those things that you will need to figure out in order to determine whether or not it's profitable to be in a particular market or produce a particular product, and how much of it to produce in order to maximize your profits. We're going to assume that firms are rational and they're going to choose the thing that has the lowest opportunity cost. They're going to go for what's the best for them. 3, we're going to think about the revenue that you can achieve for your product. And at this stage of our series, we're going to still assume that the market is competitive and that the prices are determined by the interaction of supply and demand amongst many producers and consumers in a market that's sort of separate from the firm. And so the firm just has to say, well, how much is the market price? And that's what they're going to be able to sell at. The best way to tackle the producer's problem is to look at an example. So we're going to focus on the production of what are called doodads. And doodads are just a piece of paper folded in half and then stapled neatly in the corner. And on screen now, I've got the production of doodads for 0, 1, 2, 3, 4, 5, 6 workers when they have just one stapler to use among the 6 of them. So you can see that they kind of get in each other's way, and the first worker can produce 5 on their own, but the 6th worker is only able to produce 1 more than when they had 5 workers. Not so great. Of course, if they had more staplers, maybe things would be different. So the first thing we want to work out is the marginal product of each worker. That's what's going to help us figure out how many workers to hire. So the marginal product just looks at the change in production from hiring an additional worker. The 6th worker here might be the best one. It's just that they can't be that productive when there's 5 of them already there, using the stapler, getting in each other's way, and so on and so forth. And so the marginal product of the first worker, it goes from production of 0 with 0 workers to 5 with 1 worker. The marginal product is 5. And the marginal product of the second worker is 4. And the marginal product of the third worker is 3. They go from 9 to 12, and so on. We can plot the marginal product on a graph where we put the number of workers on the horizontal axis and the number of doodads produced on the vertical axis. And I've marked in a couple of points here on the graph. 1 worker produces 5 doodads, 2 workers produces 9 doodads, for an increase of 4 doodads, so a marginal product of 4. Then, when we add a third worker, well, it can produce 12 doodads for a marginal product of 3. So the marginal product here is declining, and you can see that in the slope of the curve. It's going up, but at a slower pace. And that kind of situation is referred to as diseconomies of scale, or decreasing returns to scale. When the more workers you hire, the less and less productive each additional worker becomes. Fairly standard outcome. The alternative to decreasing returns is increasing returns, and in such a situation, every additional worker would actually produce more than the previous worker. Very uncommon, and if you can find a business that is that productive when they add more workers, you should invest heavily. And then of course, there's always the unique case of a situation where there's neither decreasing nor increasing returns to scale, but actually constant returns to scale. This is a kind of a situation where each worker is exactly the same as the other. They don't get in each other's way, but they're also not complementing each other. They're not able to help each other, like in the situation of increasing returns to scale. So constant returns to scale just means the first worker produces 3, the second worker can produce 3 as well, so for a total of 6, the third worker also produces 3, and so on and so forth. Now that we know how doodads are produced, fold them over, you staple, and we know how many are produced by the different number of workers, we need to consider the costs of producing doodads. The first 3 costs we're going to consider are what are known as fixed costs, then we're going to talk about variable costs, and total costs, which is just the sum of fixed costs and variable costs. Fixed costs just are costs that don't change as you produce more. So you have 1 stapler, you have to pay for the stapler no matter how many doodads you produce. But variable costs are things like the paper and the staple and the number of workers. The more you produce, you need more workers, you need more paper, you need more staples, but you still have that fixed cost of the stapler. To work out total costs, just add up the cost of the stapler, the workers, the paper, and the staple. In this example, we're going to assume that a stapler costs just $5, and that's your fixed cost. No matter how many doodads you produce, you're going to stay at a fixed cost of $5. The variable costs then refer to the cost of the workers, the paper, and the staples. And in this example, we're going to assume that each worker you hire costs $5, and each piece of paper and each staple costs $1. So if you hire one worker and they produce 5 doodads, well, the worker costs $5, you're going to produce 5 doodads, so that's 5 pieces of paper, that's also $5, and then you're going to need 5 staples, again, $5. So for a total of 15, which is 5 for the worker, 5 for the staples, and 5 for the paper. And you can fill in this information in the table with the fixed costs of 5, and then the variable costs of producing 0 being 0, and the variable costs of having one worker who produces 5 doodads being 15. And then you can think about the variable cost of hiring a second worker. Again, that's $5 more for hiring the worker. They can produce 4 more. Their marginal product is 4. So there's $4 more staples, $4 more paper, for a total variable cost of 28. And then you can fill in that information for each worker, 1, 2, 3, 4, 5, 6, and the output for each worker, and then the costs, the fixed cost of 5 and the variable cost of the worker plus the paper and the staple. Next, we need to look at the marginal costs, because fundamentally what we're going to do is try and work out supply here. So marginal cost is just the change in total cost from producing one more unit of the good. And notice in each of these situations so far, it's been an increase of 4 or 3 or 2, so we got to be careful. Then we're going to talk about average fixed cost, average variable cost, and average total cost. Average fixed cost is just the fixed cost divided by the output. Average variable cost is just the variable cost divided by the output, and average total cost is just the total cost divided by the output. Filling in that information in the table, the marginal cost of the production of the first worker is calculated by thinking of the change in total cost. So it goes from a total cost of 5 when you've got no workers to a total cost of 20 when you've got one worker, for an increase in cost of 15. But that's not your marginal cost, because that one worker can produce 5 doodads. So the marginal cost is 15 divided by 5 to get the marginal cost of one doodad. So 15 divided by 5 is 3. Same thing for the second worker. The total cost of having 2 workers who produce 9 doodads is 33. That's an increase of 13 from that second worker. That worker produces 4 doodads, so the increase in cost is 13, but we want to work out the marginal cost of one doodad, so divide by 4 and you get a marginal cost of 325. You can fill in this information in the table. Next, let's turn to average total cost, and then we're just going to divide the total cost by the output level. So for one worker, the total cost is 20, the output is 5, so the average total cost is 4. We're going to do the same thing for average variable cost and average fixed cost. You take the average variable cost of the first worker, that's 15, divide it by the output 5, the average variable cost is 3, and then take the fixed cost of 5, divide it by 5, which is the output of the worker, and you get an average fixed cost of $1. Notice that the average variable cost of $3 plus the average fixed cost of $1 adds up to a total of $4, the average total cost. So average total cost is equal to average fixed cost plus average variable cost. And you can see that in the table. Now you know the costs. You know the marginal cost, the average cost, and all of these things are going to help you figure out how much profit the firm can make, what's the best choice, should they enter this market, should they leave this market. All these kinds of questions are answerable with this information. The third component of the suppliers or producers problem is revenue. And in this example, remember, we're assuming that the market is competitive, the price is set by the interaction of suppliers and buyers in the market, and this particular firm has no say over that price. So in this example, the revenue from selling an extra doodad is just the price of the doodad in the market. And in this example, we're going to assume that the price is $4.50. Note, later in this video series, we're going to have situations where the firm can choose the price, and so when they produce more, they have to lower the price, and so on. But for now, we're going to assume the market is competitive. So looking at the revenue from 12 units produced is going to be 12 times 450 for a total of $54. You can see that in the table on screen. The revenue from producing 14 will be 14 times 450 for a total revenue of 63. So now that we know the costs of producing, how the good is produced, and the revenue that you would receive from producing the good, we're ready to think about what the firm is going to do to maximize its profit. Well, for that, we need to set up a table where we look at the total revenue from some number of workers and the total cost of having that number of workers, and then pick the best option. Such an approach would be a total value analysis. And in the table on screen, I've got the total revenue and the total cost associated with each number of workers. And what you can see is that the best option, the one that maximizes the profit, is where you've got 4 workers for a total profit of $10. That just means the firm is going to hire 4 workers, and those workers are going to produce 14 doodads. They're going to sell them for $4.50, and they're going to make a profit of $10. That's their best option. That gives us 1 point on the supply relationship. A price of $4.50, the quantity supplied is going to be 14. If we change the prices, we can then recalculate the total revenue and the total cost of each product, and we can then work out what the firm's best option will be. And with those different prices and the different quantities, we can map out the entire supply relationship. Note, you should make sure that you know why each of these numbers in this table are the way that they are by actually looking at what would happen if the price was $3.50 or $7.50 and so on and so forth. As always, you can do these questions using total value analysis or marginal analysis. On screen, I've got the marginal costs associated with each level of production. And all we need to do to figure out the supply relationship is say, well, what if the price is $1? Well, that doesn't cover the marginal cost of producing the first 5 units, so you don't produce them, so you stick at 0. But if the price increases past $3, then suddenly, because that marginal cost is assumed to already include all of the potential opportunity costs of your choice, then as long as the price is above $3, you do produce those 5 units. If the price increases above $3.25, then you'll produce an additional 4 units. You'll hire that second worker and produce those units, and you'll make a profit. If the price increases as far as $4.50, you'll produce 14 units. And in that way, you can map out the entire supply relationship by just considering what would the firm do at various prices given the marginal cost of their choices. Note that this method works well, except for the case where the firm might have a price that covers their marginal cost, but their fixed costs are so high that actually they're going to be not profitable. And we're going to talk about that more in the next video. Speaking of the next video, that's enough for now. In this video, we've really taken a closer look at the producer's problem, looking at the production process, the costs of producing a good, and the revenue that you can receive from that good in order to determine what will be the profit maximizing choice for a firm and how much will they produce at various prices, the supply relationship. In the next video, we're going to consider how the information that we have about average fixed costs and average variable costs and average total costs help the firm to determine whether or not they should continue producing, whether they should shut down for now, a short-run decision, or exit a market, a long-run decision. And we'll talk about the difference between the short run and the long run in the next video.